To see their relation, we will use the confusion matrix. The confusion matrix can be used to look at the performance of a classifier in the form of a table. The rows correspond to the ground truth and the columns to the model predictions or the model outputs. The cells in the table correspond to the number of elements corresponding to each ground truth model prediction combination. For example, in the cell we would have the counts where we have a ground truth of disease and a model output of positive at the same time. So here we have this and then this example. So that's two examples. The sum of these four cells should be the total number of examples, which is 10. These four counts are more generally known as true positives, false negatives, and true negatives. We've seen the formulas for the computations of each of these metrics in terms of counts. Note that they directly correspond to cells in the confusion matrix. For instance, PPV deals with the count here of the top left cell divided by, in the denominator, this column over here that gives the total number of examples where a positive prediction was made. Another metric, specificity, is looking here at the number of negative and normal, which corresponds to the bottom right cell here, and in the denominator to the total in the bottom row here. That's looking at all of the examples where the ground truth is normal. So we can represent all of these metrics in terms of these four terms. So here's the transformation of the formulas to use the terms in the confusion matrix. For instance, PPV is now true positives divided by true positives plus false positives. Thus, the confusion matrix can be used to derive all of these four metrics that we've looked at to evaluate the performance of a model.